Hello and welcome to Math with Mike. This is a new format that we're doing, so as always, let me know what you think. Today, we are going to be talking about fractions. And you may be like, I know about fractions, okay? Why are we talking about fractions? Let's do something harder. I learned that in the 4th grade. I want you to stop that thinking. Stop it. Don't think like that. A lot of people, that seems to be like their biggest crux. And that's what I see with a lot of my students. When they get to trig and calc, they're like, oh, I know this stuff. But it doesn't go away. Fractions are never going away, and they're the number one place where I see people making mistakes. And they get really embarrassed and they don't want to talk about it and they don't want to go back to those basics. But those basics are the fundamental foundation. And if you're not constantly practicing it, guess what? It's going away. The brain, as I've talked about before, is like a muscle. You're literally building it as you build connections. You are quite literally building connections between neurons, and you're strengthening them the more you do it. So bear with me. Let's play around and let's get the basics of fractions, okay? So when I have a fraction, often we don't think about what it is, right? But a fraction is always secret division. It's always me cutting stuff up. All right, so if I have 1/2, we can all probably visualize 1/2. What that's really saying is I've got something and I'm cutting it into 2s. The bottom, or the denominator, that guy is always telling me how many pieces I have. I've got 2. And the numerator, back up. The denominator is always telling me how many slices I have. Like if I had a pizza and I cut it up, that's what I meant by that. The numerator, the top number, numerator, bear with me. I always struggle with how to spell this one. Fun fact, if you're new here, I'm extremely dyslexic. Let's go. Numerator, we're sounding that guy out. Awesome. That's telling me how many of the slices I have. So here I've got 1 of my 2 slices. That's what I got going on. Or I took something and I divided it by 2. And that would get me the same thing, right? Because if I did 1 divided by 2, that's 1/2. That's 50%. That's 0.5 fractions. They're all around us. That sounded like a conspiracy theory. We'll go with it. So, we're going to take that idea and we're going to talk about how we add fractions. And weirdly enough, like you think of addition as the easy thing, but weirdly enough, adding fractions always seems to be the hardest part, right? So let's talk about it and let's talk about what's actually happening in the situation, okay? So if I'm adding a fraction, let's say, we'll do an example to start, and I'll talk about why that works. Let's say I'm adding 1/2 plus 1/4. Well, the thing in my brain that it tells me to do right away, right, my first instinct, and my favorite wrong answer would be if we just add it across. 1 plus 1 is 2, 2 plus 4 is 6. That seems pretty logical. It's a pretty logical wrong answer, but it is wrong, okay? And let's look at what's actually happening here so we can see why this would be wrong. If I have 1/2, I've got, again, my pizza, and I've got 2 slices, and I've got 1 of those slices, right? And I always like to think of addition problems as like, I'm trying to fit all of the leftover pizza into a box, so I need to know like how much will make one whole thing, how many boxes I'll need to like store my pizza, if that helps you at all. I always like thinking about math problems as something I enjoy because then it makes me happier to think about it. Try it out, see if it works for you. And then I've got 1/4. That's saying that I'm slicing this in to 4 slices. Okay, I've got 4 slices of pizza, and I've got 1 slice left. Boop, 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 boop. All right, well, if I said I had 2/6 of a pizza, that would be me cutting it up into 6 slices. So I'm gonna badly cut that up into 6 slices. There we go. And it's saying I have 2 of them. Okay, I think we can right away see that that makes no sense, right? If I'm adding these 2 together, I'm not gonna somehow end up with less pizza. That'd be insane. The only way to account for that is if your friend keeps on like stealing the pizza as you're putting it away, which would be a jerk move. So don't do that. That's not what's happening here. So let's look at what actually would be the answer and how we could get that. Yeah. So if I add together these guys, the amount of pizza that I'd end up having left is I'd have that 1/2, right? That guy's gonna be there. But I also have this 1/4 slice. Burp. But how do I figure out what that is as a fraction? Well, what if I cut up this pizza to be just as many slices as this pizza? Because if they were all the same amount of slices, I could easily count that up. That would help me figure out how much is there. Well, I think we can all easily see how I can cut 1/2 into be 1/4. I just have to slice it again. So then here, I would end up with 2 slices. 1, 2, and I still have the 1 slice here. So altogether, I'd have 3 slices. So that would go in my numerator, right? Because that's what's representing how many slices I have left. And then the amount of spaces that were in these guys, they each ended up with 4. And in the end, I had 4 slices, like spaces for pizzas, ways that it was cut up. That was the size of my slice. So I'd end up with 3/4. Kind of neat. And now you're like, okay, that's great, but like, how do I do that without having to draw a bunch of pizza slices on my paper? Because that's gonna look weird and get really tired really fast. Well, let's take a look. If I had this guy and I wanted to change this to be something I can add together, what we did here is we made it more slices. We took this fraction and we went, hey, yo, I need you to look more like this guy. It was all like, why can't you be more like your sister? Sorry, that was a bad joke. I only have bad jokes. So we've got to change it. So I think to myself, how can I change 2 to be the number 4? Well, I'm going to multiply it by 2. I can do 2 times 2 to get 4. And that's kind of what we saw here when we cut it in half. So I can take that 1/2 and I can multiply the denominator by 2. But here's the thing, if I just multiply the denominator by 2, I'm not really changing the fraction to be the same thing. I'm making it a different fraction. So we actually have to do something that is my absolutely favorite thing to do in math. It's my favorite little trick, is we're gonna multiply it by 1, because I know anything, like if I did 1/2 times 1, that's gonna be 1/2. Anything times 1 is gonna be the thing you multiplied it by. So I'm just gonna multiply by a really clever 1. I wanna multiply the bottom by 2, so I'll multiply the top by 2. Because right here, 2 times 2 over 2, that's just 1 whole. That's saying I've got 2 slices, and I have both of them. I cut my pizza into 2s, and I have both those slices. That's a whole thing. That's 1 whole. So I can do that. And I end up, 2 times 1 is 2. 2 times 2 is 4. 2/4 is the same as 1/2. That's also what we saw up here. 1, 2, 3, 4, 2 of them were filled in. Nice. And I know that this is going to be 1/4. I don't have to change that guy up for this. So I have in the end 2/4 plus 1/4. Now, as soon as your denominators are the same, as soon as they're the same size slices, I can start combining them and seeing how many I have in total. So 2 plus 1 I can do that on top, 2 plus 1. And I know the bottom is going to stay the same. It's just going to be 4. Because I'm not changing how big the slices are anymore. That's just their size. That's all that number is saying, is what size slice do you have? And the top is counting up how many we have. So I end up with 2 plus 1 is 3. I've got 3/4. I'll give you a moment to write that down if you need it. And as always, feel free to pause this video at any time if you're taking notes. And then we're going to try some together, okay? We'll try some of these. It's okay if you're feeling weird right now, or if you're like, that was a lot, that went too fast, you kind of said words at me and they didn't quite go in. That's okay. Take your time, take a breath, rewatch it, or stick with me and try the problems we're about to do. Because it's never about getting it the first time. It's okay if you don't get it the first time. It's okay if you don't get it the second time. It's okay if you don't get it the 10th time. What's not okay is giving up. You can do this. It might just take longer than somebody else. And that's okay. No one said you had to go at the same speed. All right, let's try some practice problems. I'm going to use my lovely eraser to clear the board. Yeah. All right. First problem that I want you to give a shot is going to be, let's do 3/5 plus, I'm going to switch this up a little. We're going to do, I'm making these up on the spot, can you tell? We'll do 1/5 plus 2 to start with. 1/5 plus 1/2. Give that guy a good old try. Pause your video now, give it a try on your own, and then unpause it when you're ready. Okay, good. Let's do it. So I'm going to continue to draw out what we're saying as well on the bottom, just to add that visual as we're getting used to it. Cool? Okay. So I have 5 1/2, right? So I've really got this in 5 slices. I'm going to do my best to draw that out. That's kind of it. And I have 1 of those. Awesome. And I want to add that together with 1/2. Okay, cool. How do I get my fractions to be the same size denominator? Well, here's one trick that's always going to work, okay? I'm going to take my opposite denominators and I'm going to multiply those together. That might sound weird. Let me show you. I know that I could get both of these to equal 10, right? I can multiply something by 5 and get 10. I can multiply 2 by something and get 10. So we're going to do that. And this technique will always work if you just take this opposite guy and multiply it by this guy. And then I take this guy and I multiply it by this guy. So what I'm doing is I'm going to multiply them by my fancy 1, but I'm picking the 1 very specifically. I'm going to multiply this guy by 2. 2 over 2. Because what I do to the bottom, I must do to the top. And then I'm going to take this guy. So that was that 2. That's where I got that from. Then I'm going to take this guy, and I'm going to multiply that by 5. I'm going to do 5 here and 5 here, because what I do to the bottom, I must do to the top. That's where I'm getting those numbers from. I'm just multiplying by my opposite denominator, because that will always work. If you're ever unsure, do that. It will always get you the same denominator, because 2 times 5 is the same as 5 times 2. So if 2 times 5, that's 10. Cool. 2 times 1, that's going to give me 2. And then I have here 2 times 5. That's, again, going to give me 10. Awesome. We got what we wanted. Perfect. They're the same size slice. 5 times 1, that's 5. And if I were to visually draw that, what would be happening here is I'd basically be cutting this guy up to be 10 slices altogether. I'd be cutting this guy up to be 10 slices altogether. Let's see if I can do this. That's 8. One more slice will do it, but where should I put it? I did this a little unevenly. There we go. Excellent. So we can see they've got 10 here. 2 of those then end up being that 1. Here, I cut it up into 10. I've got 1, 2, 3, 4, 5. Excellent. And now I can combine these pizzas into the same box and figure it out. Not the color I wanted. So I do 2 plus 5 and get 7. That's counting up how many slices of leftover pizza I had. And then I'm not going to change this 10. I'm not going to add them together to be 20 because that's just saying how big is the slice, right? And that's how big the slice is. 10 of them make a whole pizza. So I end up with 7/10. Awesome. All right, let's do another one. Another one. Yeah. All right, let's try a subtraction problem because it's going to be the same exact thing, okay? So try it with me. Do a subtraction problem. Let's do 6/8 minus 2. Oh, that's going to be a big one. I don't know if we could draw it out. Let's try it. Let's try it. It'll be more theoretical this time. Give this guy a good old try. Pause your video. Try subtracting 6/8 from 2/5. Okay? All right, we're back. Good. Let's give it a try. So, again, I have to change my denominators to be the same number. I need them to be the same size slices. Otherwise, I don't know how many I have altogether. So let's do that with my trick I showed you before, where I take the opposite denominator and I multiply it by everything going on over here. All right, let's do that. Oh, I accidentally erased it. Great. All right, and then I'll flip-flop and I'll do it with the 8. So 5, I'm going to multiply by a fancy 1 over here, which is 5/5, so that it ends up being the same size fraction. And over here, I will multiply by 8. 8, 8. And again, the reason why I'm doing this is because I know that 5 times 8 is going to be the same as 8 times 5, right? That's the same thing. See, we got 5/8, 5/8. So we're going to get the same fraction on the bottom. We're going to get the same denominator. Excellent. So I'm going to do 5 times 6. And that's going to give me, mental maths, 30. And then I'm going to do 5 times 8 mental maths. That's going to give me 40. See why I said we're going to end up with a lot of slices here? I'm not going to draw out 40 slices of pizza for you. That's getting a little hard. But it's the same concept. They'd be the tiniest slices, right? It'd be like that meme where it's just like, it's enough slices. So I'm just gonna write that one. I hope we're cool with that. All right, and then I'm gonna do the 2/8 and the 5/8. All right, I've got 2 times 8, that's 16. 5 times 8 still is 40. And now I can add this together. So sorry about like the light reflection. It is a pain to light this, I'm not gonna lie, because the board is reflective. If it wasn't reflective, we wouldn't be able to wipe it clean, but it's a pain to try and light. All right, we've got 30 plus 16. That's going to be 46. It's not wrong if you don't sing the answer, but it is less right. Just keep that in mind. And then we are not adding the 40s together. That's just how big the slices is. Oh, I added instead of subtracted. This is a subtraction problem. I got so sick into my ways that I forgot what we were even doing. Well, it works the same way with subtraction. I'm going to keep that in there. I'm not editing that out. We all make mistakes. So always double check that at the end. All right, so we're subtracting. So I do 30 minus 16. That's what I was saying. It's like the same thing, right? All it's changing is instead of adding these to be 46, we're going to subtract 16 from 30. So 630 minus 16, that is going to be 14. Woo! And again, I'm not going to subtract these. It wouldn't make much sense if I did, right? Because 40 minus 40 would be 0. And it's like, okay, well, how do I have 0-size slices and still have 14 of them? Doesn't work. Can't do that. That makes no sense. What are you even talking about? You sound crazy. So the slices are the same size. I have 40 slices. Hooray. Ooh, and we can actually do something here. We can make this a smaller fraction. And you're going to be like, but you said we're cutting them into slices. That's a hypothetical to help us understand if they could merge back together. But we should always reduce our fractions. So let's talk briefly about reducing. When I reduce my fraction, I want to think about what could I divide both of the numbers by? What could I divide the top and the bottom by? Because just like when we multiplied, when we divide by them, we have to do it by the same number. We have to do it to both the top and the bottom. Otherwise, it's not going to be the same fraction. We're just going to, divide by 1. Because again, dividing by 1, it's just going to be that same number. That's why it's my favorite. It's neat. So let's do that. 14 and 40. Those are both divisible by, This one's divisible by 2 and 7. This one's divisible by 4 and 10 and 2 and 20. Well, 2 is the same. I can also look at them and go, hey, I know those are both even numbers. And you know what even numbers have in common? They're all divisible by 2. So if you're unsure, you can always start with that if you notice that they're both even numbers. So let's do that. Divide by 2, divide by 2. Excellent. 14 divided by 2, that is 7. And 40 divided by 2 is 20. And now I'll look at them and go, hey, can I divide 7 by the same thing I can divide 20 by? And the answer is no. 7 is prime, and I cannot divide 20 by 7. If you don't know what prime means, it means that the only way I can get it is to multiply 1 by itself. I can only do 1 times 7 to get 7. That's all there is. It's prime. Excellent. So that would be our final answer in that situation. Thank you for learning with me today. I hope it was helpful. Have a wonderful rest of your day. I am so proud of you.